Hi everyone, this is Brad. I am going to be doing a video on programming a Productivity 1000 PLC from Automation Direct. What we'll be doing today is setting up the PLC to start with some inputs and some outputs, power supply, that sort of thing. And then we're going to go into programming a system where we will pump from one tank to the other tank as shown in this picture. You'll notice I have a float switch showing in tank 1, a float switch showing in tank 2. I have a pump, I have a flow switch, and I have a valve with a position sensor on it. What will happen is when flow switch T1 activates, in other words, this tank gets full enough to turn on the float switch, we're going to open this valve. We're going to check this valve with the position sensor to make sure that it is actually open. We're going to turn on the pump, and then we're going to confirm flow with the flow switch. Now the other side of this is if the flow switch or float switch in tank 2 becomes active, that tank's full, we will shut this pump down and not pump any more into tank 2. So that'll be what we're going to work on today. The next thing in this is to open up the PLC programming software and build it up so that we can get started. We are going to go ahead and open up our Productivity Suite 3.716. We're going to start a new project. We're going to choose which CPU we're going to use, and in this case I have a CPU P1 550. Now I'm going to go ahead and go to hardware configuration. I'm going to click on my CPU. I'm going to add the power supply that we're going to be using, and it's the P1-01 DC, and we bring it over here and we put it before the CPU. We're going to say OK. Now the next thing we're going to do is I have an input and output card already with my system, and so I'm going to add those in. We're looking at the P116NE3. We're going to say OK. Now we're going to put our output card in, and the output card is a P115TD2. We're going to add that in. Okay. So now we've set up all the inputs and outputs we need for this particular project. So we're going to close out the hardware configuration. Well, now we're going to have two different tasks that we're going to run with this program. If you look down here in the lower left corner, you'll see the tasks folder, and there's some different ways that you can run tasks. For this particular project, we're just going to run the tasks that we put in on every scan. What that means is that every scan of the computer, this will read through the tasks that we have in here. There's some other ways to run these tasks, but for our purposes, we're not going to use any of those on this particular project. So what we have right now is a task called New Task. We are going to right-click on it, and we're going to rename that task. And we're going to call that Tank Controls. Whoops. Enter. Now we're going to be using a second task in here also. So I'm going to right-click on Run Every Scan. I'm going to create another new task. This new task is going to be called alarms. And later on in this video, we will be setting up some alarms for different things within this particular program. So for now, I'm just going to say okay. All right. So now we have set up the two different tasks that we're going to run for this program. Now, what I need to do is I'm going to make some changes in my uh, hardware tags database. So let's go up here and let's go to our hardware config. Okay, we're going to rename some tags here for our digital inputs and digital outputs. Okay, so for digital input number one, we're going to do the float switch. So we're going to do a lowercase level switch ls underscore t1. Enter. Okay, so we're going to do the same thing here for 2 level switch underscore p2. Oh. Whoops, we're going to go back to this one here and put our, try and keep them the same. We're going to do an underscore here. Oh. Okay, enter. The next thing that we're going to do is create the digital input for the flow switch. So we're going to do a underscore flow switch underscore 1 in case we add another one later on. Okay, now we're going to do the valve position switch. Now you notice I left the DIs in here. I did that for a reason. Let's go ahead and do the we're going to call this valve 1 because we may add underscore and we're going to say open. Okay, let's see. So we have our two tanks, our flow switch, and we have our valve open. I think that's all of the digital inputs that we have. So we're going to say okay to that. I started to say the reason I leave the DI in there is these will make it easier for me to find when we go to use these in our program. They'll all be kind of grouped together as DIs, and it'll just make it easier for me to find it. Okay, so we've done that now. We're going to have two at this point, two digital outs, right? We're going to have one for valve 1. V1, digital output for V1, and we're going to have one that's for the valve. So we're going to have one for pump 1. V1. Okay. So now, when we open these up, we're going to look and we're going to see our digital ends. Let's see. Okay, we have one for tank 1, tank 2 level switch, flow switch. This should just be FS, not FRS. Flow switch 1 and valve 1 open. Okay. Well, I forgot one. We're going to need we're going to have a start switch in here that is really just a run stop switch. So let's go ahead and open up our digital inputs again. And we'll make this one run stop. Enter. And so the run position will be a true input on this. Okay, one of the other things is I'm not going to go into tremendous uh, training on how inputs work and so forth. Let's assume that the people who are watching this video already understand how an input works and what an output does. Real simply, an input is when we get a signal from something coming in, then that's an input. So let's say we were doing a light switch. If I put a light switch on an input here, when you turned on the light, the input would go high. I'm not going to go into any real great detail on these because I'm going to assume that if you're watching this video, you have a little bit of background and understand how digital inputs and digital outputs work. So from here, we're going to actually get ready to start doing our programming. So I'm going to close out the hardware now. Now here's our ladder diagram for our tank controls. Let's go ahead and make sure that we're on tank control. So I'm going to double click here. Okay. So right up here it tells us we're in our tank controls. So what's the first thing I said was going to happen? The first thing that I said was going to happen was that our float switch was going to engage. But before that even happens, we need to make sure that our start run is in the run position. So let's come over here. Here's our instructions on the right hand side, and what I'm looking for is a normally open contact. I'm going to drag that over here. Now I'm going to look for my digital inputs. I can come here, I can pull this down until I get to D's. Here's our digital inputs. And here we go. Here's the ones that we renamed and gave tag names. So here, this first one, let's say that we're looking for our run stop to be in run mode, which would be 1, which would be true. Okay. There we go. Now, if we're in run mode and our float switch becomes true, let's drag it over here. So let's just this time type in DI. Oh, there we go. Now we just looking at DIs. Oh, level switch for tank 1. Okay. We're starting to build our controls here. All right, the next thing that we're going to do, we said that if tank 2 was full and turned on, we were going to stop our pumping. So how are we going to manage to do that? What we're going to do is we're going to bring in a normally closed contact and put it over here. That means if tank 2 high is not true, then this line of code is going to operate. So again, we're going to do DI. We're going to come down here and drag down. And we're going to look at tank 2 level switch. Okay. Now, okay, so those are the conditions that we need to have met before we open up our valve. So now let's bring our valve in. So we're going to come over here, and I'm not going to go into a lot of these different ones. Some of these I've never used, so I really haven't had a chance to work with them. But in this case, I'm going to use an output coil. Now we're going to type in digital out. Let's go down. There we go. So we're going to open up our pump or our valve now. So if we're in run mode, tank 1 level switch becomes true and tank 2 level switch is not true, saying that it's overfull, then we're going to open up this valve. That's really the controls to start the system. So now, what else did we do here? We actually added a position switch for valve 1. Now we're going to get ready and bring in our pump. Now we've already given it all the conditions for all of this stuff to happen and to bring on valve 1 and hold valve 1 in. So what would happen if we're pumping down and tank 2 got full? This digital output is going to turn off. Okay? So we're going to look to add a set of normally open contacts in here on our second line of code. Okay? We're going to look for a signal from that, digital out, for valve 1. So what that means is if this output is on, it's going to say that this input is on. It's just saying that this is energized, that this output has been energized. So the next thing that we want to do is we want to make sure that the valve is actually open. So we're going to come down here again and we're going to look at our digital inputs. Okay. Digital input V1 open. So now, not only does this output to the valve have to be on, but also the V1 position sensor has to say that that valve is open. So what are we going to do now? Okay, next thing we're going to do is add another output coil here. D-O. Let's go find our pump control. There it is. And we're going to say OK. So now we have built what I was talking about. These controls are all in place. If we're in run mode and tank 1 float switch becomes true, saying that it's full, and the level switch in tank 2 doesn't say that it's overfull, then valve 1 is going to come on. That output is going to come on, and we're going to check that in the code for the pump and make sure that output is actually on, which it is, and that the valve position sensor says that the valve is actually open. Now we're going to actually engage and turn on the pump and start moving fluid from tank 1 to tank 2. Okay, so there's a couple of different things that can happen to stop this whole process. Number 1, tank 2 can get full, or the level switch for tank 1 drops down enough that it's no longer energized. So that looks pretty good. So we've actually got our controls in place now to run our pumps. I'm going to go ahead and save this. There we go. Now, just for the heck of it, I'm going to go ahead and come in here and I'm going to compile the project. Okay, so it completed successfully. There was no errors. Hi, everyone. We're now going to create some alarms for this same program that we've already written. We're going to have a couple of different alarms. One of the alarms is going to be for tank 2 when the float switch triggers on tank 2 saying that that tank is full. So let's go ahead and do that code first. Okay, here we go. Normally open contact. We're going to stick it there. And we're going to look for the digital input for tank 2 float switch. Limit switch tank 2. Okay. Now we actually need to create a output that will be a internal memory bit. It won't be a physical input. This will be a bit that will only exists inside the PLC. So since it's going to be a Boolean bit, we're going to name it MB, and let's call it tank 2 high limit. Now, when I say OK to this, we're going to create this. So this is a memory bit that is of a Boolean type for tank 2 high limit. We're going to say OK. Now, whoops, that is actually incorrect. That shouldn't be an OR out. That should be a regular output coil. So I'm just going to grab this and put it in here. It's going to ask me if I want to change the OR out to an output cable. I'm going to say yes. Okay. So now what we need to do, once this limit switch triggers, we want to latch this alarm in. So what we're going to do is we're going to come here, we're going to use control down arrow, and we're going to put a parallel bit in here. We're going to take normally open contact and put it in there. And we're going to use this MB tank 2 high limit. MB tank 2 high limit. So what will happen is once this comes on and triggers, this will latch it in. Now we have one more thing that we need to create, and we need to create a reset digital input. So we're going to go back to our hardware configuration again, open that up. We're going to open this up. And this next bit in line here, we're going to create a reset. Whoops. Button. So that'll be a hardwired reset button. Okay. So now if we open this back up, that should be there. Okay. So let me close this and close this now. Now, this button is going to be a normally open button that when we push it, it's going to close the circuit. So in this case, we actually need to use a normally closed contact. I'm sorry, let me move this up here and grab this normally closed contact. We're going to put it here and we're going to make it DI. And we're going to call this the reset button. So what's going to happen is when you push that button, this is going to become true. This input is going to become true, and it will actually open this up and reset the output as long as the limit switch is no longer being held in. So we're going to save this. Okay, now we're going to set our alarm up so that if tank 1 limit switch turns on and then does not turn back on turn back off within a certain period of time, we're going to set off an alarm. We're going to assume that that limit switch or that float switch will turn back off at around 60 seconds of the pump running. So what we're going to do is we're going to add a little time to that. We're going to set it up the same way we did for tank 2, except we're going to look at the tank running. So let's go ahead and set that up. All right, we're going to add a normally open contact here. We're going to look for the digital output for the pump. Okay, P1 is running. We're going to again find a normally closed contact and add it here, and we are going to look for the digital input for the limit switch on tank 1. Okay. We're going to again create a timer. So let's go down here and find our timers. There it is, a simple timer. We're going to add it here. Okay, we're going to make this one actually operate for, if it's 60 seconds normally, we want to give it a little leeway, so we're going to give it about 80 seconds. Okay, and we're going to change this to seconds. And now we're going to create an alarm for this one. We're going to call it memory Boolean underscore tank 1 high limit. We're going to say OK to that. And again, we're going to create this memory bit here. And we're going to say OK. Now again, we need to do the same thing that we did before. We're going to create our latch. Okay. Normally open contact. We are looking for MB, tank 1 high limit. Okay. We're going to come here and do control left arrow to close that up. And again, we're going to do our reset button. We're going to copy. And I like to move it out here a little bit. We'll paste it here. Okay, so that alarm is also set up. So what we need to do now is we need to create a new network. So we're going to come back up here to network 1. We're going to insert a rung before. Okay, there's our new rung. Now what we're going to do is we're going to copy the tank 2 high limit. We're going to paste it here. We're going to come here. We're going to again do a down arrow. We're going to copy the position alarm. Paste it. Again, we're going to come out here and we're going to do our last one, our tank 1 high limit. Now we're going to again, we're going to add an output coil here. Out coil. And we're going to go ahead and create a new memory Boolean. Oops. Memory Boolean underscore, and let's call this system alarm. Okay, we're creating it again. There we go. So now if we look at what we've done here, we've created all of our different alarms in here, but we've actually created one master, in essence, master alarm bit. But we have one more alarm to set up for this unit, and that would be the flow switch. So let's go ahead and get that one set up. Again, we're going to be looking for the pump to be running. So let's just copy that output for the pump and put it here. And now we're going to be looking for a digital input for the flow switch. Okay, that'll be a DI. Flow switch. Okay, but again, don't we need to make that a normally closed contact. And yes, we're going to change that. So we're going to do the same thing we did before. We need to go here first. I'm sorry, a little out of order here. We're going to add our output coil here. We're going to call this MB. Whoops. MB. And let's call this flow alarm. Okay. Again, we're making a memory Boolean bit. Okay. Now we're going to come back here. Normally open contact, our latching circuit. Go MB, flow alarm. Okay. We're going to close that up. And we're going to copy our reset bit. Paste it here. Okay, but we have a problem here. We're going to need a short delay for that also. So instead of having just this output bit, we're going to come back over here again and get a timer, simple timer. And yes, we're going to replace that with a simple timer. We're going to make it 5 seconds. We should have flow within about 5 seconds of starting that. Change this to second. Going to make that MB flow alarm. And we're going to say, okay. 5 seconds, flow alarm will come on. Again, it'll be latched in. So now we need to come up here again and add this to our system alarms. The open contact. Do the flow alarm. Okay. So now we have our alarms active here. We're going to save this. We're also going to go ahead and go in and do a compile. And there's one more thing that we need to do here. We're going to come around to our tank controls. And in this first line, we're going to add this alarm bit. We're going to put a normally closed in here. System alarm. Okay. So as long as that's not active, valve and our pumps will run. When that becomes active, it's going to turn and drop all of this out. So we again have V1 will close up and P1 will turn off once we have a system alarm. And I am actually going to go into our tag database. As I see, I have a spelling mistake. We're going to go to MV system alarms. And we have a K there that does not belong. backspace. We're going to close this, and it should have corrected it here, and it did. Now we're going to save this again. We're going to do a compile, and everything was successful. So for our little simple system, this should do it. This is pretty much everything that we need to run this little simple system. Later on, we're going to add some other controls to this system, but it will be in another video. So we're going to save this system for now, and then when we get ready, we'll make some additions to it. We're going to put some level detectors in the system that'll give us feedback via analog, and we'll be able to test levels with that analog sensor, and we'll be able to control our pumps through that. But for the moment, this will do it, and this is the end of the first training video. Thanks a lot for watching.